Okay, good afternoon, ladies and gentlemen. It's very hot today. So, my solar panels actually absorb so much heat to produce solar energy. That's my first solar panel. My second batch of solar panels are this one. Okay. The sun is very bright today and it's hot. It's around 90 here at Los Angeles, California. This is the connection that goes inside. Okay. On the first solar panel, group of solar panels, which are three, this is the connection that goes inside. So they are all connected in parallel, merged into two lines here that goes inside. It goes inside here. Okay, so that's the entry point going inside. So the two group of solar panels actually goes inside the house. This is the first three solar panels. They are all connected in parallel. The next one is also three. So this is first group, second group. They are connected in parallel. The goes back at the back here. And they enter the what you call this solar charge controller. The input to the solar panels are this one here. This is a 100 ampere switch which protects the circuit from any short circuit just in case. So right now the voltage coming from the solar panel is 12.3. Okay. Let's try to see how much the current. The current is 12.1 amperes. Current is 12.1 amperes. Voltage is 12.3. Okay. So this is the solar charge controller which controls the charging voltage going to the battery. The output of the solar charge controller, actually this is the positive terminal. This is the negative terminal. So right now, okay, these two batteries are actually being charged. Okay. So this is actually, they are connected in parallel. And this is the power source of my inverter. This is my inverter. This is the plus connection that goes to the back of the solar inverter, and this is the minus connection. Okay, and this is the entry point. This is the plus coming from the battery. This is the minus coming from the battery also, and it powers up this 2400 Samlex power inverter from Canada. So right now the inverter is have so much power. It is on now. Okay, this is the plug-in thing, and this load here is actually our refrigerator. So the load right now is a refrigerator, and since the juice coming from the sun is so much, actually the charge coming from the battery is so much to power up this 2400 watts. What you call this sinusoidal inverter. Okay. This is the input voltage. This is the load. The load is not so much because it is just a ref. Okay. So the connection of the rep is actually this one here. This one. Okay, that's going to the rep, and it is plugged in here. So the power source of the rep right now is actually this solar inverter coming from outside. And as you could see it, if we try to see it, this rep is actually working. It's working. So this rep now is being powered by solar energy coming from a power inverter. Okay. That's it. So I think this is the right time to use the solar energy because the sun is too much. It's very hot here. The temperature outside is 90 degrees Fahrenheit. So actually, even if you watch television, you plug in your this extension here, you could watch your TV using this solar inverter. Okay. For the meantime, my other inverter is inactive. I'm not using this one. The only one I'm using is this one here, and this is rated 2,400 watts. Okay. Okay. That's the specification. 1,500 watts inverter. 12 volts DC, 110 volts AC. See, the voltage coming out from this what you call this convenience outlet from the inverter is 120 volts. This is free. Okay. So right now, this is the right time to use solar energy. It's free. So this rep here is not plugged into the convenience outlet coming from the utility line. The power coming from the sun right now is so much, so I'm using this inverter here as a power source for my rep. Like right now, before the sun goes down, it's even if it is around 8 o'clock here in the USA right now, it's summertime here. The sun is still very high and it's very hot. Okay. That is just the connection of my solar power equipment. It's just a simple one. I will repeat it. I got two groups of solar panels outside. They are all connected in parallel. One group is one circuit. Another group is one circuit. They enter the house through here. First circuit, second circuit. They goes back outside here. The input of the two circuit outside enter the solar charge controller. They enter here. This is the plus and this is the minus. Like what I said. Okay. That's the voltage right now, 13.7. And since the battery are almost fully charged, the current right now is just 2.1. That's why the voltage goes up to 13.7, but the current goes down because it seems the battery are not fully charged. So the charging process is very easy. You know, the connection is just a clip one here. Okay, that's the plus, that's the minus. So this plus and minus here is the accumulation of the two groups of solar panels from outside. And this charges the two 100 ampere hour battery, which is the power source of the solar inverter. So solar inverter, the power input is actually DC and the output is AC. And since refrigerators need alternating current, we use this one as a load for this power inverter. Good afternoon from Los Angeles. This is Professor David J. Vilches. That's the zip up of my solar equipment, which I use it during times of the day in which the sun is actually very bright. Good afternoon.